Today we are looking at mixed numbers and improper fractions, and we know that 1 2/4 is equal to 6/4. We're going to prove that today with our math models. And we're also going to add a new word, the simplest form. Pause the video here and talk about what is your thinking about these two fractions. Why are they equal before we build anything? And what do you know about this term, simplest form? Pause the video and have a quick discussion. Okay, let's first prove that mixed number 1 2/4 is the same as the improper fraction 6/4. I know I'm going to need my fourths because both of them have fourths, and I have a mixed number, so I'm going to need some wholes. Go ahead and get your fraction tiles or fraction strips out and prove to us that these two fractions or numbers are equal or equivalent. Pause the video now. Okay, let's see. Did you build 1 2/4? And then prove it equal. I guess I don't need that whole. Prove it that it equals 6/4. Let's see. If I build it, I can see I have 1 2/4 and 1, 2, 3, 4, 5, 6. 1 2/4 does equal 6/4. Go ahead and pause the video here to give some practice to drawing this now. Try drawing it as a tape diagram and a number line. Let's see what you drew. I'm going to start with two tape diagrams this time. I want to show that 1 is equal to 1 2/4 and 1 is equal to 6/4. Dividing by fourths, I think, is more easy because I know half and then half of a half is a fourth. So I kind of organized. Now I need to make sure my lines line up on both of these tape diagrams because I'm comparing two numbers. I want this to show that they are equal. My two tape diagrams are the exact same length and size, and so I can easily show this. Well, I'm going to show that 1 2/4. I'm going to color in 1 2/4. And I might even want to label this, I can see as one whole, so I might want to show that this is 1/4 and this is 1/4. You decide what you need to organize to label clearly. And I want to show also that this is equal to 6/4. So I might even show this as 1 whole and 2/4. And I might even count up on this one just to show that it equals the 6/4. And when I'm finished, I should be able to see, oops, not 5, 6, it's 5/4 and 6/4. I can easily see that these are equal. I'll do the same thing on my number line. Partition into fourths. Label, we have 1/4, 2/4, 3/4. 1 whole is 4/4. I need to label that. 5/4, 6/4. I can go all the way. What would 2/4 be? Or excuse me, 2. 2 would be 8/4. I want to label that. And so I'm looking for 1 2/4. So 1 2/4 is here. And I can also see that it's 6/4, so I'll probably mark that and circle that to show their equivalent. Now, let's talk about simplest form. This was our word for today, simplest form. Is there another fraction tile I can use that would be less fraction tiles? It would be simpler. Which fraction tile would equal fourths, but it would be less tiles? Pause and have a talk about it. Okay, if I look, I notice that a half is equal to 2/4. That's simpler because it's only one fraction tile for every 2/4. That will be much easier to build. And if I even compare it to the whole, I can see that 2 wholes is 1, 2, 3, 4 halves. So that makes me think, if I'm saying 1 and 2/4, I can look and I can see it's the same as 1 and 1/2. That is simpler because it is less fraction tiles. It is a smaller denominator. So I could also say that 1 and 1/2, which is much simpler, it's much easier to use halves than fourths, there's less of them, is equivalent to, I want to use halves again. What would you say for the improper fraction? Look at the model and what would it be? Well, let's look. 1 and 1/2 is the same as 1, 2, 3 halves. The simplest form of the same mixed number and improper fraction is really 1 and 1/2 is the same as 3 halves. These are equal. What other fractions can you make in simplest form?